Okay, dah. Assalamualaikum and very good evening to Dr. Sobri. Today, my name is AMIRA BINTI AHMAD SAKRI. Today, I would like to present you about dielectric resonator antenna from material to its application. By the way, this assignment being complete by our group, which is group 32. As for introduction, an antenna is a device of converting electromagnetic radiation in space into electrical current in the conductor or vice versa, depending on whatever it's being used or for receiving or transmitting respectively. Antenna is actually divided into two categories, which is microstrip patch antenna and dielectric resonator antenna. For today, we're gonna explain you more further about dielectric resonator antenna. Okay, the dielectric resonator antenna, also known as a DRA, is an antenna that make use for a radiating mode of a dielectric resonator, DR. The DRA is fabricated from a low loss and high relative dielectric constant material, which varies from a 3D shape, whose resonant frequencies are a function of size, shape, permittivity of the material. The 3D shape of the device, which is hemisphere, spherical, cylindrical, rectangular, and triangular. The shape of material actually will determine the potential waveform that could be output of a DRA. Okay, some of the DRA interesting character, like a small size, ease of fabrication, high radiation, increase of widthband, and low production cost. It is actually very promising for application in wireless communication. For the DRA material, the material itself is actually typically made of ceramic, glasses, or low conductivity.
I'm HAKIM from group 32, and I will continue our presentation. It is basic shape of the electric resonator or DRA and their advantage. There are three common shape of DRA, that is cylindrical, hemispherical, and rectangular shape. And this is their feature. And I will explain about cylindrical shape. Cylindrical shape, it gives a flexibility, variation of radius that control the resonance frequency and the Q factor. And fabrication is much easier, and very smooth, can be easily excited. Result in either broadside or omnidirectional radiation pattern, and the resonant waveguide cavity are not very practical in the cylindrical shape. Cylindrical shape also offer 1 degree of freedom more than hemispherical, because it has aspect ratio and the Q factor for given the dielectric consonant. For hemispherical shape, it offer an advantage over the rectangular and cylindrical, such as interference between the dielectric and air is simpler and characterized by a and the hemispherical shape is characterized by a radius, which is mounted on ground plane that has infinite connectivity and infinite extent. The transverse electric and transverse magnetic are one of the modes in the dielectric sphere. Transverse electric mode have a zero value for the radiational component of the electric field, and while transverse magnetic modes also have a zero radial component of the magnetic field. For the rectangular shape, it offers a second degree of freedom, which is more than cylindrical and two more than hemispherical shape. It provides designer to have a greater design flexibility to achieve the desired profile and bandwidth characteristic for a given resonant frequency and dielectric constant. The resonant frequency of each of these modes will be a function of the dielectric resonator antenna dimension. The designer can avoid the unwanted modes to appear over the frequency band during operation by choosing the dielectric resonant antenna dimension. For the feeding, then I will go through the feeding method of the electric resonator antenna. There are 5 feeding method. That is coaxial feed, slot aperture, microstrip line feed, dielectric image guide, and coplanar coupling. For coaxial feed, coaxial can either be placed adjacent to the dielectric resonator antenna. The amount of coupling can be enhanced by adjusting the probe height and the dielectric resonator antenna location. Various modes can be excited depending on the location of the coaxial and coupled directly into a 5 ohm system without the requirement for matching the network. Probes are suitable at a lower frequency where aperture coupling may not be applied due to the large size of the slot required. And for the slot aperture, exciting slot aperture excite through an aperture in the ground plane upon which it is placed. Aperture coupling is applicable to the dielectric resonator antenna of any shape such as rectangular, cylindrical, or hemispherical. The aperture works like a magnetic current running parallel to the size of the slot, which is excite the magnetic field inside the dielectric resonator antenna. Aperture type of feeding consists of a slot cut in the ground plane and fed by a microstrip line below the ground plane. Feed network is located below the ground plane. The coupling level can be changed by moving the dielectric resonator antenna with respect to the slot. And we will go through the microstrip line feed. Microstrip line feed the connecting strip is connected directly to the edge of the patch. And common method for coupling to the dielectric resonator in microwave circuit is by proximity coupling to the microstrip line. Microstrip coupling will excite the magnetic field in the dielectric resonator antenna to create the short horizontal magnetic dipole mode. Level of coupling can be changed by the lateral location of the dielectric resonator antenna with respect to the microstrip line and the relative permittivity of the DRA. Microstrip line can be used as a series feed for linear array of dielectric resonator antenna since it offers ease of fabrication and simplicity in modeling along with impedance matching. As the thickness of the dielectric substrate being used, rise surface, wave, and superior feed radiation also rise, which hamper the bandwidth of the antenna. And we will go to the dielectric image guide. The dielectric image guide offer advantage over microstrip at millimeter wave. At millimeter wave frequency since they do not suffer as several from conductor loss. Dielectric image guide offer advantage over microstrip at millimeter wave frequency since they do not suffer as severely from conductor losses. As with microstrip line, the amount of coupling to the dielectric resonator antenna is generally quite small, especially for the dielectric resonator antenna with slower permittivity value. Although it may be possible to increase the coupling by operating the guide closer to the cutoff frequency. And it best utilized as a series feed to a linear array of dielectric resonator antenna. And the last one is coplanar coupling. The coplanar coupling. The coupling behavior of the coplanar loop is similar to coaxial probe, but the loop offers the advantage of being non-obtrusive by moving the feed loop from the edge of the dielectric resonator antenna to the center. One can couple into either the HE11 sigma mode or the TE011 mode of the cylindrical dielectric resonator antenna. The coplanar waveguide or CPW is such transmission line that can achieve high radiation efficient demand. And that's all.
Hi, Assalamualaikum. My name is AHMAD. So I am also part of the group 32. So, okay, as we know, the title of our mini project is dielectric resonator antenna. So I will go into advantage of using the DRA. Okay. So this is some of advantage of dielectric resonator antenna, such as low conductivity, and then we got broadband connection, also compact design, and we also have simplicity design. So let's go to low conductivity.
Oi.
Alright. Okay, low conductivity. When the machine uses DRA technology, it will give you the less signal interference to the machine. So this will make the machine useful in emergency situation or in tracking job, such as the phone. It has a GPS technology to tracking or to give you way to where you want to go. So that is why DRA is also used in phone. So it is because it will less the signal interference. Alright. Next, the advantage of DRA is broadband connection. Okay. Dielectric resonator antenna will give the machine or the technology, the material that use DRA, the longer range or different frequency as from low to high. This is to avoid interference by other device. So when it also provide a cheap phone service via VoIP technology. Okay, let's go to next. Next advantage of DRA is compact design. Okay, as we know, dielectric resonator antenna is built in a small size, so it will easily merge and can be used in smaller device because it is small in size. It also not diffuse or verbose, and then because it's small, so it will occupying a small volume by reason of efficient use of space. So this will make the device or the material that use DRA can have more available or more bigger available space because the DRA is just a small pieces. Okay, and then we go to the last point of advantage is simplicity in design. Alright. Why the dielectric resonator antenna is simplicity in design? It is because it only has 3 main components. So it just only has 3. So the first one is metal ground plate, and then we got cylindrical material, and then the last one is power source. So by these 3 components, it will complete the circuit. Alright. Because it is easy to build. Why it is easy to build? Because it is like we know, simplicity in design. So it not complicated to build. And then when when it is easy to build, it will affect the cost to build it. It will be more, the cost will be more effectiveness and moderate. So it will not go too expensive because it's not too complicated, and we will not have to get more additional cost or anything. So that is 4 advantage, and there's a lot more advantage by using the dielectric resonator antenna.
With application, the first application is Wi-Fi and Bluetooth. It's good for a broadband connection due to its long range ability. The second one is defense, military, radar, military wave application. It's flexible in the electric resonator antenna. They can be designed with a different shape or as per our requirement, depend upon the application in the wireless communication world. Smaller component allow it to add more extra feature. Next one is good replacement for the microstrip antenna. The dielectric resonator antenna has a much wider impedance bandwidth and higher power handling capability due to their many advantageous feature. The next one is bandwidth wireless local area network, which is what we call it WLAN. The design with a coplanar waveguide feeding is obtainable for the bandwidth wireless local area network WLAN application. The achievement is impedance bandwidth above 20% of 4.96 GHz to 6.07 GHz, covering complete WLAN band and especially getting wideband with a dual resonating frequency at a popular island at 5.2 GHz and 5.84 GHz band. The last one is by 5G technologies. It's aimed to increase the data rate of a wireless communication network by factor of large waveband, high gain, small size and temperature independent performance on the design of a radio frequency electronic. However, due to its loss in a conductor and dielectric substance material, it suffers from a low radiation diffraction and narrow band behavior. Actually, the RA did not suffer from a conduction loss and characterized by high radiation efficiency when excited.
My name is HAZLAMI, and now I explain about conclusion and feature scope. Okay, for feature scope, the first point is fabrication and measurement. Pipe-shaped DRA with roger material and other design DRA will be carried out in the future. Next, since the impedance bandwidth of DRA antenna can be enhanced by using multiple DRAs, design of dielectric resonator antenna using embed technique will be carried out in future. And besides the experience of designing DRA with microstrip line feeding, dielectric resonator array with the dielectric image guide feeding can further be designed to minimize the metallic losses. Okay, now for the conclusion. There are many types of DRA has been studied, and the types are pie-shaped DRA, which is rectangular step DRA, and T-shaped DRA. For rectangular step DRA, it provides dual band application, while T-shaped DRA provides dual band wireless antenna application. Okay, that's all from us. Thank you.